Hi, and a very special welcome to this video tutorial. The purpose of this video tutorial is to help high school students, especially those in Africa, to really appreciate and understand basic science concepts, especially physics. In this tutorial, we are going to talk about the concept of density and relative density and how they apply in our everyday lives. We will start with the concept of density and later talk about the concept of relative density. And so let us go right into the discussion. What is density? What does the density of an object describe? Well, the term density comes from the root word dense, which describes how heavy an object is. And so when you are talking about the density of an object, we are describing how heavy or light that particular object is. Heavier objects are said to be dense, while lighter objects are said to be less dense. If we want to arrive at the density of a particular substance, we need to know the mass of the substance and the volume of the substance. When we have the mass of the substance and the volume of the substance, we will divide the mass by the volume. The result is what we refer to as density. So we realize that the density of an object is the ratio of the mass of the object to its volume. Scientifically, we define density of a substance as the mass per unit volume of the substance. Mass is measured in kilograms and volume is measured in cubic meters. And so the SI unit of density is kilogram per cubic meters. Sometimes too we can measure the mass in grams and the volume in cubic centimeters. And so the density of an object can also be measured in gram per cubic centimeters. Alright. Sometimes in our computations, it will require us to change the unit of either the mass or the volume to another for us to be able to solve a question. In the course of this tutorial, we will address that. But for now, we want to talk more about the formula for density. That is the mass divided by the volume. In fact, the definition of density is the mass per unit volume of the substance. We want to lay emphasis on the per unit volume. What does this mean, per unit volume? It means that we are considering 1 cubic centimeter of the volume of the substance or 1 cubic meter of the volume of the substance. That is the amount of matter contained in 1 cubic centimeter of the substance or the amount of matter contained in 1 cubic meter of the substance. To further explain this point, let us consider the density of water. The density of water is known to be 1 gram per cubic centimeter. What this means is that for every 1 cubic centimeter volume of water you take, you would find 1 gram of the molecules of water there. The density of water can also be 1000 kilogram per cubic meter. This means that if you measure 1 cubic meter of the volume of water, and you measure the amount of water molecules in this volume of water, you are going to get 1,000 kilograms. If we take any other substance and have its density, the same explanation will go for it. For example, if we take a piece of stone and the density of that piece of stone is 5 kilograms per cubic meter, what it means is that for every 1 cubic meter of the volume of the stone, the mass or the amount of matter in that 1 cubic meter of volume is 5 kilograms. And so that is the concept of the density of an object. If the density of an object is more than the other, it means that the object with a higher density has many particles in just 1 cubic centimeter of its volume, or 1 cubic meter of its volume than the other. Back to the formula for density, which is density is equal to the mass over volume. If you are given any two of these three quantities, that is density, mass, and volume, you should be able to find the third one by making it the subject. For example, if you are given the density of a substance and its volume, you can find its mass. In this case, the mass of the substance will be equal to the product of the density and the volume. In the same way, when you are given the mass of an object and the density of an object, you should be able to calculate the volume of the object. So the volume of the object will be the mass of the object divided by its density. Now we want to look at the relationship between density and volume and density and mass as contained in this formula. When we look at the formula for density very carefully, we can conclude that density and volume are inversely proportional, which means that as you increase the volume of a system, its density would decrease, and as you increase the density of a system, its volume would decrease. So from variations, we can write the formula for density as rho is inversely proportional to volume, and we know that we can remove the sign of proportionality and bring an equal to sign and a constant, and that will bring us back to the formula, which is rho is equal to m over v. In this case, it means that the mass becomes the constant. Alright, what about the relationship between mass and density? We would realize that mass and density are directly proportional. This means that as you increase the mass of a system, you automatically increase the density, and as you decrease the mass, you automatically decrease the density. That is why sometimes when a ship with cargo or a boat with goods is sinking, we decide to offload some of the goods, because by offloading some of the goods, you reduce the mass, and by reducing the mass, you automatically reduce the density of the system. We want to further explain the relationship between density and volume. And so let us consider this wooden rectangular box of dimensions 30 centimeters by 20 centimeters by 10 centimeters. And so the volume of this box would be 6,000 cubic centimeters. Let us assume that we fill this rectangular box with a sample of garden soil to the brim and weigh the whole content on a scale. Let us assume that the whole content weighs 500 grams. So we can calculate the density of this system. That is 500 grams divided by 6,000 cubic centimeters. And we are going to arrive at 0.083 grams per cubic centimeters. Now we want to reduce the volume of the system but maintain the mass. We want to keep the mass constant. So let us take another wooden box, this time of length 20 centimeters, of width 10 centimeters, and of height 5 centimeters. The volume of this box will now be 1,000 cubic centimeters. We fill this with the sample of garden soil, weigh it, and we assume the mass is again 500 grams. So the mass is constant, but this time it is the volume that has changed, it has decreased. So by calculating the density of this system, we are going to have 500 grams divided by 1,000 cubic centimeters, and that is going to give us 0.5 gram per cubic centimeters. Now let's analyze. We realize that the densities of the two systems are not the same. Although the masses are the same, the densities are not the same. This is because their volumes are not the same. In the first case, we had a volume of 6,000 cubic centimeters and it translated to a density of 0.083. We now reduced the volume to 1,000 cubic centimeters and it translated to a density of 0.5 gram per centimeter cube. So we realize that as we reduced the volume of the system, the density rather increased. This shows that density and volume are inversely proportional. Having had this particular understanding, let us do some analysis with some conceptual understanding. Let's assume you have two objects, A and B. The mass of object A is MA and the volume of object A is VA. Let's say the mass of object B is MB and the volume of object B is VB. If these two objects have the same densities, if the amount or the value of their densities is the same, what would be an expression relating MA, VA, MB, and VB? Pause the video and do it on your own, and then we'll cross-check our answers. Alright, if the densities of A and B are the same, then we can say that the density of object A is equal to the density of object B. That is, in symbols, row A will be equal to row B. So the density of object A is the mass of object A divided by the volume, which is MA over VA. This will be equal to the mass of object B divided by the volume of object B, that is MB over VB. And this is the equation relating MA, VA, MB, and VB. I'm sure you had it correct. Now let's take a second scenario. Assuming this time the density of object A is twice that of the density of object B, what will be the relationship between MA, VA, MB, and VB? Once again, pause the video, work through it, and then let's cross-check our answers. Alright, if the density of object A is twice that of object B, then we can say that the density of object A is equal to 2 times the density of object B. In symbols, row A is equal to 2 row B. We are going to have the density of object A being equal to 2 times the density of object B. So in symbols, we are going to have MA over VA is equal to 2MB over VB. Let's try a third one, this time solely on U. Let us assume that object B is 1/3 of object A. What will be the equation connecting MA, VA, MB, and VB? Try it on your own. Let's take this question also. The mass of a sample of garden soil is 50 kilograms. It was poured into a rectangular box of mass 10 kilograms, measuring 50 centimeters by 40 centimeters by 60 centimeters. If the sample of garden soil is now poured into another rectangular box for 1/5 of the volume of the first one, but having the same mass as the first one, find the density of the new system. I want you to pause the video, try it on your own, and then we will go through. Alright, and so let's see. According to the question, the sample of garden soil has a mass of 50 kg and the box has a mass of 10 kg. The mass of the system is 60 kg. Let us calculate the volume of the first system. We are going to have 50 centimeters multiplied by 40 centimeters multiplied by 60 centimeters. And that would give us 120,000 cubic centimeters. In standard form, we are going to get 1.2 times 10 exponent 5 cubic centimeters. Because our mass was given to us in kilogram, our volume must also be in the correct unit, which must be in cubic meters. So let us convert our volume into cubic meters. By converting the volume into cubic meters, we are just to substitute the value of the C, that's the centi, and cube it. So we are going to get 1.2 times 10 exponent 5 times 10 exponent 2 all to the power 3, because the centi is a value, that's the C, and it is 10 exponent 2. And because we are dealing with volume, we are dealing with cube, we have to cube the value. And so when we do the computations, we are going to get 0.12 cubic meters. So this is the volume of the first system. Now the question said the second system has a volume that is 4/5 of that of the first one. So to calculate the volume of the second system, we have to find 4/5 of the first system. So the volume of the second system is going to be 4/5, which is 4/5 times 0.12 cubic meters, and that is going to give us 0.096 cubic meters. The question is now asking us to find the density of the new system. So the density of the new system will be the mass of the system divided by the volume. Remember, the same mass of garden soil was put into the rectangular box, and the rectangular box, although has different volume, has the same mass, and so we are going to have 60 kilogram divided by 0.096 cubic meters. So when we do the computation, we are going to get 625 kilogram per cubic meters. Now let us compare the first system to the second system. We would realize that the volume of the second system decreased, and so there is an increase in the density. If we should calculate the density of the first system, we are going to get 60 kg divided by 0.12 cubic meters, and that is going to give us 500 kilogram per cubic meters. The difference is clear, and the concept too is very, very clear. Now let us focus our attention on the volume of objects. The volume of an object represents the space the object can occupy. Although for regular objects, the volume can be computed by taking the dimensions. We can equally use a measuring cylinder to take the volume of objects, especially irregular objects. We know from our knowledge in density and the volume of irregular objects that when you pour water into a cylinder and you lower any object into the cylinder, there is going to be a rise in the volume of the water, and the difference between the initial volume and the final volume of the water is equal to the volume of the object you have placed in it. So in case you don't know the volume of an object, you can use this method to determine the volume, and it is very, very accurate and very, very interesting. Alright, we would realize that as you put the object into the cylinder containing water, there will be a displacement of the water. That is, there will be a rise in the volume of the water. Scientifically, we say there is a displacement of the water. In other words, a volume of the water has been displaced, and the volume of water displaced is equal to the volume of the objects placed in it. So let us represent the volume of water displaced by VWD and the volume of the substance by Vs. And so we can establish an equation which is very useful here, that the volume of water displaced is equal to the volume of the substance. That is, VWD is equal to Vs. Now let us brainstorm a little. Some objects can float more than the other. In other words, some objects can sink more than the other. And so the question is, if an object sinks in a container of water more than the other, is there any difference in the volume of water that is displaced? The answer is yes. The more deeper an object sinks in a liquid, the more liquid it will displace. For example, if I drop an object in a cylinder of water and the object sinks completely, the volume of water displaced will be more than when only half of the volume of the object sinks. In this case, it means that if half of the volume of the object is in the liquid, it will displace a volume of water half of its volume. For example, if the volume of a piece of wood is, say, 50 cubic centimeters, and after putting it in a bowl of water, half of its volume is immersed in the liquid, it means that the volume of water that will be displaced will be half of the volume of the wood, which in this case is going to be 25 cubic centimeters. Sometimes we are interested in the weight of the volume of liquid displaced. So how do we get weight out of volume? Let's see how that one can be done. We know from theory that the weight of an object is equal to the product of the mass times acceleration due to gravity. In symbols, we say W is equal to mg, where W is the weight, m is the mass, and g is the acceleration due to gravity. Let us label this as equation 1. Alright, then from density, we also realize that density is equal to mass over volume. Let us make mass the subject here. So we are going to get mass is equal to density times volume. Let us now substitute this second equation into the first equation. We are going to copy equation 1. Wherever we see m, we put density and volume there. So we are going to get W is equal to rho V G. And this is the formula for finding the weight of the liquid which is displaced. The weight of the volume of liquid displaced is equal to the density of the liquid times the volume of liquid displaced times gravity. Now, since weight is the product of mass and gravity, and at the other side of the equation we also have gravity, we can write this equation as mg is equal to rho L times VLD, that is the volume of liquid displaced, times gravity. And since g, or gravity, acceleration due to gravity, is at both sides of the equation, we can divide both sides by g, and we are going to have m is equal to rho L times VLD, that is the mass of the volume of liquid displaced is equal to the density of the liquid times the volume of the liquid displaced. And so this is the beautiful concept of density of objects. Before we move to the concept of relative density, I want you to brainstorm a little on these two questions. Number 1, under what condition will a substance float in a liquid? And number 2, under what condition will that same substance sink in a liquid? Alright, now let's take 2 examples on how to calculate for the density of an object. Alright, now let's do 2 computations on the density of an object. Our first question reads, an object of mass 20 kilograms has an area of 25 squared centimeter and a height of 4 centimeters. Calculate its density in kilogram per cubic meter. Alright, let's see how we are going to solve this question. Let us put the information given in the question down. So the first information is the mass of the object, which is 20 kg. The second information that we have to calculate, the second information given in the question is about the volume of the object, but it was not given directly. We were given the area and the height. And so when we multiply the area and the height, we would get the volume of the object. So the volume of the object is equal to 25 cm squared times 4 cm. This will give us 100 cm cube. But since the question has asked us to calculate the density in kilogram per meter cube, we have to convert our 100 cm cube to meter cube. How do we do that? It's very, very simple. By the way, in order to really know how to convert units in a very simple way, check out our video, which is coming very soon, on unit conversion. But for now, we know that centi is a prefix and it is 10 exponent minus 2. So we just place it there, and because we are dealing with cubes, you cube it, and so we are going to get 1.0 times 10 exponent minus 4 cubic meters. Therefore, we have found our volume. So the next step is to substitute the values and then find the final answer. So the density of the object would be equal to the mass of the object divided by the volume of the object. Now the mass of the object is 20 kg divided by the volume, which is 1.0 times 10 exponent minus 4 meter cubed. So finally we are going to get 2.0 times 10 exponent 5, that is 200,000 kilogram per meter cube. In physics, we normally advise that we leave our answers in standard form. Alright, let's take another example. A rectangular block of mass 1.2 kilograms is 10 centimeters long and 5 centimeters wide. Calculate its height in centimeters if its density is 8 gram per cubic centimeter. Alright, so let us put down the information given in the question. We have been given the mass of the block, which is 1.2 kilograms. But because the question asked us to calculate the height in centimeters and the density is given in gram per centimeter cube, let us change this mass in kilogram to grams. And so by conversion, we multiply 1.2 by 1,000 and we are getting 1,200 grams because the kilo means 1,000. Okay, the second step is now to find the area. Area is length times the width. So area of the block would give us 10 centimeters by 5 centimeters. That is 50 centimeter squared. Now that we know the mass of the block and we know the density, what is left for us is to calculate for the volume, and in the volume we are going to get the height. So we know that volume of the block is the area times the height. The area is 50, and so you are going to get 50h, where h represents the height. So let us quote our formula for density and substitute in the values. So density of the block will be equal to mass of the block divided by the volume of the block. And so density is 8. We substitute to the 8 is equal to mass of the block is now 1200 divided by the volume, which is 50H. Now, by making H the subject, we are going to get H is equal to 1200 divided by 50 times 8. And by computation, our H is going to be 3 centimeters. It's as simple as that. I would like to give you this question for your own practice. A body of mass 0.02 kilograms has a volume of 250 cm cube. Find its density in gram per cm cube. Let me give you a clue to the answer. The answer will give you 8 times 10 exponent minus 2 grams per cubic centimeter. I hope you can solve and get the answer. Let us now move to the second aspect of our tutorial, talking about relative density. The word relative connotes comparison. When we are talking about relative density, it means we are comparing the density of two objects. Sometimes it becomes very necessary to compare the densities of two objects. The question is, why? Why is it necessary to compare the densities of two substances? Why do we have to relate the densities of two objects? The concept of relative density actually applies very much when traveling on sea. When traveling on sea or on any other water body, we have to make sure that the density of the ship or the boat is less than that of water, so that the boat or the ship will not sink. In this case, we have to compare the density of the boat to the density of water, and this brings the concept of relative density. Because of this, the standard substance that we usually compare the densities of all other substances to is that of water. The density of water is known to be 1000 kilogram per cubic meters, or 1 gram per cubic centimeters. When we really want to explain the concept of relative density, we have to find the ratio of the densities of two substances, the one we are looking for and that of water. The relative density of an object is the ratio of the density of the object to the density of water. As simple as that. The ratio of the density of the object to the density of water. Let us express this in a formula. That is, relative density of an object is equal to the density of the object divided by the density of water. In terms of symbols, we can have ρD, that is the relative density, is equal to rho O, density of objects, over rho W, density of water. Sometimes too, the relative density of substances can be expressed only in terms of their masses. In this case, the relative density of a substance will be mass of any volume of the substance divided by mass of equal volumes of water. So we have to be careful that the volume of the substance you are using is the same as the volume of water. That is, if the volume of the substance is 20 cubic centimeters, the volume of the water must also be 20 cubic centimeters. Now let me ask a tricky question. What do you think is the unit of relative density? Well, it has no unit because it is a ratio of two densities or a ratio of two masses. So their units cancel themselves out. As already illustrated, if the density of an object is more than that of water, it will sink in the water. But if the density is less than water, it will float in the water. So let us assume we have a piece of wood, and the density of this piece of wood is 1200. The question is, will this wood sink in water or will it float in water? We know that it will sink in the water because the density of this wood is more than the density of water. And this is where relative density comes in here. So we can find the relative density of the wood, and it will be relative density of wood is equal to the density of wood over the density of water. Since we have the figures, let us substitute. We are going to have 1200 kilogram per cubic meters divided by 1000 kilogram per cubic meters, and we are going to get 1.2 as our answer. If we have another wood which has a density of 800 kilogram per cubic meters, will this wood float or will it sink in water? We know that it will float because the density of the wood is less than the density of water. When we are calculating the relative density of this wood, we are going to get 800 divided by 1000, and that is 0.8. Now let's do a little of brainstorming. I like brainstorming a lot. Let us compare the relative densities of these two woods, 1.2 and 0.8. How does the relative density of an object tell us whether or not it will float or sink in water? If the relative density of an object is greater than 1, then it will sink. But if the relative density of an object is less than 1, then it will float. And these two examples about the wood really explains that. The first wood has a relative density of 1.2, and we know it sinks. But the second wood has a relative density of 0.8, and we know it floats. So this is how the concept of relative density really help us in the concept of flotation and sinking of objects. Now let us do some computations. Number 1, a liquid has a relative density of 0.8. If its mass is 10 grams, calculate its volume, and we have been given the density of water as 1.0 gram per cubic centimeter. How do we solve this question? We have been asked to calculate the volume of the liquid, and we know the mass of the liquid. In this case, we only need the density of the liquid for us to find the volume. So we are going to find the density of the liquid first using the formula for relative density. But first of all, let's put down the information given in the question. So the relative density of the liquid is 0.8. The mass of the liquid is 10 grams. So let's quote our formula. Relative density of the liquid is equal to density of liquid over the density of water. Since we want to find the density of the liquid, let's make it a subject. So the density of the liquid will be equal to relative density of the liquid times the density of water, which is going to give us 0.8 times 1.0 grams per cubic centimeter, and that is going to give us 0.8 grams per cubic centimeters. Now that we know the density of the liquid and the mass of the liquid, we can find its volume. So the volume of a liquid will be equal to the mass of the liquid divided by the density. And so the volume will be equal to 10 grams over 0.8 grams per cubic centimeter. And the final answer is 12.5 cubic centimeters. So the volume of this liquid is 12.5 cubic centimeters. Let's take another question. A piece of rock has a mass of 1,500 grams and a volume of 3.5 times 10 exponent minus 4 cubic meters. Calculate its relative density. And the density of water has been given as 1,000 kilograms per cubic meters. So we are supposed to calculate the relative density of the rock. The relative density of the rock is the ratio of the density of the rock to the density of water. And we know the density of water. So all that we have to find is the density of the rock. And so the density of the rock will be given by the mass of the rock divided by the volume of the rock. So let's put the information given in the question down. Mass of rock is 1,500. But since our volume is given in meter cube and the density of the water is also given in 1,000 kilogram per meter cube, it is advisable to convert the mass in grams to kilograms. And so 1,500 grams is equal to 1.5 kilograms. Once again, you can check out our video on conversion of units. The volume of the rock is 3.5 times 10 exponent 4 cubic meters. So let's find the density of the rock, which is mass of the rock divided by the volume of the rock. In this case, we are going to have 1.5 kilograms divided by 3.5 times 10 exponent minus 4 cubic meters. And we are going to get 4.3 times 10 exponent 3 kilogram per cubic meters for the density of the rock. Now that we know the density of the rock, we can now find the relative density of the rock, which is the density of the rock divided by the density of water. So by substituting the values, we have 4.3 times 10 exponent 3 kilogram per meter cube divided by 1,000 kilogram per meter cube. And so our final answer is going to be 4.3. That is the relative density of the rock. And since 4.3 is greater than 1, it means the rock is going to sink in the water. We are about to come to the conclusion of our video tutorial, and I would want to leave you with some conceptual questions. You can solve these questions and share your solution with us in the comment section. hope you have found this video very educative and you would want to continue studying with us, and therefore I humbly ask you to subscribe to our channel, like this video and share with your friends. See you in the next video.